7th wall. And today, our project idea is to make a wheelchair that avoids obstacles. As you know, like the disabled, they might be unable to turn like an electric chair. So we thought of doing this by modeling it as parts due to economic constraints. And we use this FPGA, the DE2115, where we had connected it, used a couple of sonar sensors to detect the states, which my colleagues will explain to you. And we also had this motor, like 4 motors on each side of the car. If we flip this, which also is connected to an edge bridge, which one of my colleagues will also explain to you the function, how all of this edge bridge connects to the states. And we finally have 2 batteries, a main battery for the car and a lithium polymer battery for this FPGA, so it won't have to use this power adapter. And now we will go to every one of the team and he will explain to you how all of these go together and how are the states modeled and everything.
Our project mainly depends on ultrasonic waves to detect obstacles. Simply the idea of the operation is that the board sends a signal of 10 microseconds on the trigger of the sensor to start measuring. Start measuring, it starts sending ultrasonic waves from the transmitter. Second, it receives these signals from the receiver part, and when it receives back, it starts an echo signal, and it keeps it on until it stops receiving. When we measure the times that the echo took to go back and forth, by physics, by dividing by the speed of sound, dividing by 2, we could maintain distance meters. Simply this happens for the 4 ultrasensors in the car in the 4 directions. Then the car uses this information to decide to start by its decision. My friends will explain now the decision process, how it works.
Okay, first of all, our project is modeled by a Mori finite state machine. I will talk about the states and the mechanism of moving the car. For the states, we have 5 states, which is moving forward, moving backward, turning left, turning right, and then stopping. Okay. The mechanism of moving forward, that all of the 4 wheels just move forward. For backward, all the 4 wheels move backward. The trick is in the right and the left turning. Okay, so when we want to turn right, the right side moves backward and the left side moves forward. So it's like this, and this guy is going backward. When we want to turn left, it's the opposite, so vice versa. So the left side is moving backward and the right side is moving forward, so it's like this. And stop, just the car is keeping stop in its place. If we wanted to implement this each wheel independently, we will need 2 edge bridges, because each edge bridge will take 2 sides. But our case here, that this side works on one side of the edge bridge, the right side will work on the other input of the edge bridge. So they are working in the same decision which we take. So if we decided that this guy, the left side, will move forward, these 2 wheels will take this decision, and the same for the right. So they are the same decision for the same side.
The initial state of the car is to move forward. If it detects an object in a range of 1 meter or less, it will listen for both the left sensor and the right sensor and determine which sensor gives the maximum distance. If the left sensor gives a distance of 5 meters and the right sensor gives a distance of 4 meters, it will take the 5 meters. Since the 5 meters greater than 1 meter, it will determine that this direction is free. It will go to this direction. If both the readings are less than 1 meter, this will mean that the left direction and the right direction is blocked, and it will move backward.
So whenever the distance forward is indicated that it's less than 100 centimeter, the car goes in the left or right state. In the left state, it keeps moving to the left direction till the forward direction is indicates that it's more than 100 centimeter distance, then it moves back to the forward state. And that's the way how it goes when it moves on the right direction. And it has an option that it can move backward when the three directions, left and right and forward, are blocked. So it keeps moving backward till one of the left or the right sensors indicate that it's not blocked anymore. So it moves back to the left or the right states, depending on the one that's not blocked anymore. While it's moving backward, if it got a block on distance less than 100 centimeter and it's already blocked on the other three directions, so the car stops.
The H bridge controls which motors work. When enable A is 1, this side, the two ways at this side works, and when the enable B is 1, the two ways at this side works. So when enable A is 1, input 1 and input 2, if it's input 1 1 and input 2 0, this side move forward. And if enable 3 and enable 4 1 0, these two ways move forward. So what is the other way around? If input 1 is 0 and input 2 is 1, then this side moves backward, and if enable 3 is 0 and enable 4 is 1, this side moves backward. So how do we make the car moves forward? If we want the car to move forward, both enables will be 1, and input 1 2 3 4 will be 1 0 1 0. And if you want to move right, both enables will also be 1, and input 1 2 3 4 will be 1 0 0 1.